Today, we are diving into the 2025 AP Calculus AB first math question, starting with question 1. We are given a function c of t that models the number of acres affected by a certain condition over time t in weeks. They even been kind enough to provide the derivative c prime of t, which represents the rate of change. Part A. Our goal is to find the average number of acres affected from t equals to 0 to t equals to 4. To find the average value of a function over an interval AB, we use the formula 1 over b minus a integral from a to b of f of x dx. So the setup is the average acres equals to 1 over 4 minus 0 integral from 0 to 4 of c of t dt. So part A asks for the average number of acres over the first 4 weeks. Remember that the average number of acres means that the average value of the function c of t. We set up integral from 0 to 4 and divide by the width of the interval, which is 4. Part B. Find the time t where the instantaneous rate of change equal to the average rate of change on an interval 0, 4. We need to find that t such that c prime of t equals c of 4 minus c of 0 over 4 minus 0. So we have to calculate the average rate. Then set c prime of t equals to the value. Then solve for t within the interval 0 to 4. So in this part, we're looking for the moment when the instantaneous rate of change matches the average rate of change over those first 4 weeks. This is a classic mean value theorem application. Calculate the slope between the endpoints, set your derivative equal to it, and solve for t. For part C, we want to check the end behavior. So, write and evaluate a limit describing the end behavior of the rate of change. So the end behavior as t increases means we take the limit as t approaches to infinity. So the setup is as follows. Limit c prime of t as t approaches to infinity equal limit t approaches to infinity of 38 divided by 25 plus t squared. So as t grows infinitely large, the denominator grows while the numerator stays constant. So the limit is 0. Part C asks about end behavior. We take the limit of the rate function c prime of t as t approaches to infinity. Since the degree of the numerator is higher than the numerator, so the rate at which acres are being affected eventually drops to 0. Part D asks about absolute maximum. So our goal is to find the time t for which a of t attains its maximum value in the interval 4, 36. So the logic is to use the given, which says a of t equals c of t minus integral from 4 to t of 0.1 ln x dx. So to find this maximum, we need the critical points, where a prime of t equals to 0. The setup is as follows. We use fundamental theorem of calculus. A prime of t equals c prime of t minus 0.1 ln t. Then set a prime of t equals to 0. So we have 38 over 25 plus t squared minus 0.1 ln t equals to 0. Now, for candidates checks, a of 4, a of 36, and at t values found in step 2. Finally, part D introduces a new model of a of t, for t greater than or equal to 4. Now, to find the absolute maximum, we find the derivative a prime of t, then locate our critical points where the derivative is 0, and then test those against our endpoints 4 and 36 to justify our answer.